Okay, in this section we are going to be looking at relations and functions and what types of relations are functions and so forth. So a relation is, in mathematics anyway, is just a, oh, that doesn't write very well, let's try this, a set of ordered pairs. Okay, and let's look at an example of this. So here we have the ages and grade levels of 5 different students. So age here would be our independent variable and y would be our dependent variable, our x and y coordinates. So our ordered pair here for the first student would be 6, 1. And then the next would be 12, 7. Then 15, 9. And 15, 10. And 18, 12. So this would be an example of a relation. These 5 students would be the different ordered pairs in the relation. Okay. Whenever we talk about relations, we talk about their domain and their range. So the domain is the possible x values. Okay, so for example, for the past example, for this one up here with the students, the domain would be the list of all of the ages right here. So 6, 12, 15, and 18. So we would write this like this. Usually we'll do x such that x equals 6. I'll put brackets around it. 6, what were they again? 12, 15, and 18. Now you will notice here that when I wrote that domain, there were 2 students who were 15 years old, but I did not write that 15 twice. So when writing the domain, do not write repeated values twice. So if a number shows up in the domain more than once, we still only write it one time. Okay, the range of a function is the possible y values. So the possible y values. Okay, and so if we look at the last function for the possible y values, I said function, it's a relation, 1, 7, 9, 10, and 12. So the range is y such that y equals, well, I've forgotten it already, 1, 7, 9, 10, and 12. Now, it did not become an issue for this particular problem, but when we are writing the range, we also do not write repeated values twice. Okay? Now, whenever we talk about relations, there is a type of relation that we're going to be really interested in, and that type of relation is called a function. And functions are really important for mathematics. We look at all different types of functions. In this class, we'll look at linear and quadratic and exponential functions, but there are cubic and quartic and trigonometric and logarithmic and all kinds of functions that we look at throughout our math career. So functions are a really big part. For a function, we have to have, this is going to be a relation where each x has, or is assigned to, I should say, is assigned to just one y value. So if we look back up here at this relation that we had up here, 6 goes with 1, 12 goes with 7, 15 goes with 9, but 15 also goes with 10. So this single x value, 15, goes with two different y values. So this would be an example of something that is not a function in this case, because one of your x's goes with two different y's. Okay, so in a function, each x can only have one y. Now, there are a couple things that can help us decide if something is a function. Right here, we're going to do something where we're going to write our domain and our range in these little circles that we have here. So in this problem right here, my domain are all the x coordinates of these ordered pairs. So I would have 3, 2, -1, and 4. It does not matter if you write them in numerical order. You can just put them as they show up, but make sure you do not write them twice. Then for my y values, I have 4, 6, 2, and I've got 6 again, but I'm not going to write it again. So now what I'm going to do, in this ordered pair, 3 goes with 4, so 3 is assigned to 4. 2 is assigned to 6, -1 is assigned to 2, and 4 is also assigned to 6. So this question asks us, is this relation a function? And in this case, if we look at all of our x's, this x has one y, this x has one y, this x has one y, and this x has one y. So this is a function. Yes, this is a function. Now, it might throw you off a little bit here because that y goes with two different x's. But this is okay. The y can go with as many x's as it wants. The x's can only have one y. So you're looking at the arrows going out here to make sure that none of those double up. Basically, the x values cannot be repeated in this list. It's okay if the y values are repeated. For example 2, we've got this function. We've got -10, -5, -10 again, and -15. It's a negative right there. Sorry about that. That's our domain for this relation. And then we have 100, 20, 0, and 200 for our range. And so if we draw our arrows to assign our values here, -10 goes with 100, -5 goes with 20, -10 also goes with 0, and -15 goes with 200. And so right here you can see -10 goes with two different y values, and that cannot happen in a function. Notice that -10 was repeated, those x values were repeated, so this is not a function. So this is one way that you can help you figure out if something is a relation or just a relation, or if it is also a function here. These diagrams that we just made are called mapping diagrams. Okay. Another way that we're going to figure out if something is a function or not is by looking at the graphs. And when we're doing this, we're going to do something called the vertical line test. And the vertical line test tells us that if a vertical line intersects two or more points anywhere, anywhere on a function. Oops, sorry. That shouldn't say function. Anywhere on a relation the relation is not a function. Okay. So if we look at this list right here, now you might prefer to make a mapping diagram. You may just go ahead and look through the list here and see that, right here, 3, 0 and 3, 2 are both in the list, so that x is repeated, so this is probably not going to be a function. But we could also look at the graph. So I'm going to graph these points. So we've got 3, 0, it's right here, negative 2, 1, it's right here, 0, negative 1, goes right here, negative 3, 2, negative 3, 2 goes right here, and 3, 2 goes right here. And so if I think of taking a vertical line, and let me see if it will let me do this here. Pick shapes, line, there we go. So if I take this vertical line right here, and let me go back to where it will let me grab this. Yep, there we go. And if I pass this through the graph, at this point, only 1 point touches, only 1 point, only 1 point. So up to here, I'm good. But when I get right here, I've got 2 points that touch that vertical line. And so in this case, is this a relation a function? No, it will not be a function. How do I go back to it? There we go. No, it is not a function. Okay. So I'm going to switch over to another worksheet that I've got here. And I just want us to look at these to see if we have functions or not. So let me add a line in here for this one. I'll make it really vertical. Okay, and so if I start with this first problem, if it'll let me, it's being a little bit hateful. There we go. If I pass this line through the graph, you'll notice that every single point, that vertical line only touches the graph once. So this would be a function. If I take this, let's see, I gotta go back to select. Okay. If I take the line over here for number 2, then once again, everywhere the line just touches once. Now you'll think right here, well maybe it's touching twice, but it's just a really steep line. We have to remember lines are infinitely thin. They don't have any width, so that's really only touching once at all those points. So number 2 is also a yes. Okay, let's scroll down here and look at these next ones. Number 3, if you pass a vertical line through this graph, let me grab it. It's not going to come with me very well because I'm not doing this correctly. This is easier whenever it's in person. Alright, we're going to pass that vertical line through only once everywhere. So number 3 is a yes. But you're probably already seeing that we've got a problem with number 4, because as I take my vertical line that I've got right here, you can see there's lots of places on this relation where the graph is going to hit that vertical line twice. So this one is definitely no, it is not a function. Okay, number 5 falls into the same category as number, as number 4. I'm having a little trouble with my line here. I need to just pick up, okay. And you can see right here, lots of places again, so that one is a no. Number 6 is a little difficult to see, but let's take our line. We'll definitely need our line for number 6. Okay, here we can see only 1 point, but right here, right there, we've got 2 points. So that only has to happen one time, and it's not a function, so this one would be a no as well for number 6. Let's continue on. Trying to drag my line down here, but it doesn't seem to want to go. I'm just going to put a new line in. Number 7 is a little bit like number 6. It's a little bit difficult to see, but if I take my line here, only 1 point, only 1 point, only 1, 1, 1, 1. And as I go across, I have not yet came across anything where I have 2 points. So number 7 is a function. For number 8, I can see very quickly right here that if I pass my line through, that I'm not going to have any problems with that one. So that one is a yes. Oh, hold on. If we go down here to number 9, I don't want to do that. Come on. Come on, line. It's so sensitive. There we go. If we go to number 9, we can see here, this one is definitely not a function. Well, I've got my line here. I'm going to look at 10. That one is a function. I'm going to skip down to 11 before I write these down. Oh, sorry about that. I'm going to skip down to 11. This one is a function, but if I take my line here for number 12, that one is not, because all of the points hit that line. So we had for number 9, this was a no. Go back to drawing. No. This one is a yes. This one is a yes. But that last one is a no. Okay. You'll have a couple assignments that you're going to look at on IXL. So sign in to IXL. Make sure you sign in or it won't give me your results. And you're going to do a couple sections there.